Good morning, student. Let's start today's class. Okay. In today's class, we are going to start your unit 6, which is solar photovoltaic. Solar photovoltaics. Okay. Your unit 5 is completed. So, from now on, we are discussing or we are studying about your unit 6, which is solar photovoltaic. Okay. Now, first of all, let's see what is solar voltaic. What is solar voltaic? Okay. The solar voltaic is a method of generating electrical energy by converting solar radiation into direct current electricity by using semiconductors that exhibit photovoltaic effect. Okay, here what do you mean by solar voltaic? Solar voltaic is a process in which we convert the solar radiation into a direct current DC electricity by using a semiconductor which exhibit or which have the property of photovoltaic effect. And that photovoltaic effect, what is photovoltaic effect is that the effect or the effect or the process in which when sun radiation is fall on the semiconductor, when the sun radiation is fall on the semiconductor, then the charge carrier is produced in the semiconductor. That means when the sun radiation fall on the surface of the semiconductor, in the semiconductor the charge carriers, that is hole or electron, generates. Okay. uh, by which the um, by using or mm, by using that charge carrier, we get our DC current. Okay. So that effect is called photovoltaic effect. And which semiconductor or those semiconductor have that photovoltaic effect, that semiconductor is used in solar photovoltaics process. Okay. And photovoltaic power generation employs solar panels composed of a number of solar cells containing photovoltaic material. That means we know in there is panels, there is solar panels which convert sun radiation to DC, and our photovoltaic process is also same. Okay. It converts incident solar radiation into DC. Okay. So here we use solar panels. Okay. And that solar panels composed of a number of solar cells. Now you see that one solar panel is like that. If that this is solar panel. Okay. There is a cell, black cell. Okay. There are many black cells. Okay. That cell is called solar cells. Okay. And that cells is connected between each other in a series or parallel manner as we record our voltage and current. Okay. If we want high current, then it is then they are connected in parallel. If we want a high voltage, then it is connected in series. Okay. So that cells have a contain have photovoltaic material or the semiconductor which exhibit photovoltaic effects. Okay. And presently used material include monocrystalline silicon, polycrystalline silicon, amorphous silicon, and cadmium, uh, uh, tellur- cadmium and telluride, and copper, indium, gallium, so etc. are used in the place of that photovoltaic semiconductor, okay, in the solar cell. Okay, more than 90% of solar cell produced at present are of crystalline silicon. Okay, crystalline silicon, where cells are exclusively based on the use of silicon wafer. Okay, that means the semiconductor in the semiconductor is the silicon. Okay, alternative structure such as silicon ribbon are also available in the market, but 90% of the solar cell use silicon wafer based uh, solar cells. Okay, then now let us see what is the fundamental concept behind the solar cell. Okay, behind the solar cell generating DC. Okay, absorption of electromagnetic radiation in semiconductor. Okay, in semiconductor material gives rise to a electrical field. The electrical effect is usable for power generation in the semiconductor. That means, uh, see, this is one cell. Okay, this is one electro. Sorry, this is one solar cell. Okay, this is and note that the solar cell have a semiconductor like PN junction. Okay, and that PN junction is used as a solar cell. Okay, and here you see the PSI silicon P type semiconductor is there, and the upper of that or above that N type silicon semiconductor is there. So PN junction happened. Okay, and bottom a metal bottom contact and upper metal contact. Okay, that two contact uh, act as a 2 point. Okay, or two pole of the solar cell. Okay, positive negative or negative positive. Okay, so this solar cell have two type of semiconductor. Okay, one p type and one p type and one n type. Okay, and that pn junction is created. Okay, the basic construction of the silicon. Okay, that this is the basic construction of silicon cell in here. Okay, given here. Then the following conditions are essentially required for generating the voltage and in, in and hence inducing current. Okay, that means that four condition are the four conditions should be satisfied for generating DC from the solar cell. Okay, first one is the solid must absorb light. Okay, the solid or the material which we used in a photo cell must absorb light. Okay, then as the result of radiation absorption, the charge carrier must be created. That means after absorbing the solar light, that semiconductor can create or should create charge carriers. Okay, and the charge carriers are of opposite sign and are separated from each other by an internal electric field. That means that how or those or that much of charge carrier created, these charge carrier created have should have a opposite sign, that is positive electron which is negative sign and hole which is positive sign. Okay, these two charge carrier pair should be created and they are separated with each other by using an internal electric field. Okay, by using an internal electric field means in PN junction there is some potential barriers. Okay, so like that here also some barriers or electrical field barrier are there. Okay, or should there. Then next is electrical contact must be available at the top and bottom of solar cell for taking of current with minimum losses. Okay, and uh, and the contact points are also in top or bottom of the plate. Okay, or the contact points should be on the top or bottom point of the solar cell. Okay, and these four conditions should be satisfied to induce current. Okay, next is the basic requirement of a solar cell is the availability of an internal electric field to utilize the photoelectric effect in the semiconductor. The basic requirement of the solar cell is that to uh, to get the internal electric field. Okay, and good to get the electric field to utilize the photoelectric effect of the semiconductor. Okay, that means for utilization of the photoelectric effect of the semiconductor and generate the electric field, we use solar cell. Okay, the creation of the electric field can be understood with the help of band theory of solid. That means the concept of generation of electric field, okay, will be understand, or electric field inside the semiconductor will be understood by using uh, band theory. Okay, and that band theory we will study in our coming class. Okay, thank you.